Good day to all of you. The session is regarding intermediate chemistry, which will be fetching for your international preparation towards entrance or competitive exam as well. India level JEE Advanced JEE Mains examination for IIT and NIT entrance, which is the technical domain. India level NEET chemistry will be there. That will be helpful for your medical entrance examination across India. Telangana and Andhra Pradesh MCET examination for BTech entrance, which is a engineering stream. In addition to all, if you are preparing for any government organized examinations called competitive exams, where general studies is the common question paper for all the aspirants. There you can find a general science as the content. The content what we are discussing will be very much helpful for that kind of preparation. Let's enter into our today's session. Explain the optical isomerism of the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. According to this optical isomerism, in turn, R and S nomenclature to be denoted. R stands for Victus, S stands for sinister, right? So if higher to lower priority moving in a clockwise rotation called R, and if we are moving in anti-clockwise manner, that is said to be S configuration. This is also called as absolute configuration, where purely this is applicable to the compounds having chirality over there. Chirality is the compulsory condition which is containing carbon surrounded with the 4 different functional groups. If this is the case, sorry, this is the compound where carbon surrounded with 4 functional groups is said to be bromo, chloro, methyl, hydrogen. And as per the Canning-Gold-Prologue rules, you have to assign numbering for them. Bromo obviously of higher atomic number resided with higher priority. Later on chloro will be there, and chloro followed by carbon atomic number, so that third priority, and move on to hydrogen least atomic number. This is the way numbering will be assigned. After assigning this numbering, we have to move from first to second priority. First to second priority, the movement is in a anti-clockwise, which is said to be counterclockwise. Moving in this counterclockwise rotation, what happens? We can denote S. But another condition to be taken into the consideration, the least priority group is on the plane. So that let me make the exchange of 2 functional groups like this. Bromo will come over here and hydrogen will go to the away from the viewer. Whenever dotted line bond with a hydrogen, so that the whatever configuration that will be inverted. Hence, it will be denoted as a R configuration. The condition, if the least priority at the back end, so that whatever rotation you are getting, that exactly giving your absolute configuration. Being it is an anti-clockwise, you have to mention it as a S. But after mentioning S, you have to go for higher priority and lower priority positioning. Lower priority on the plane, so that let me put over backside. Whenever it is moving backside, the entire configuration got inverted. This is the way our configuration to be mentioned. And let me give the IUPAC nomenclature for the given organic compound. Being it is 1 carbon, so that 2 carbon chain. 2 carbon chain, ethane will be the parent skeleton, and we have to assign name according to alphabetical order. B comes first over C, so that R is the absolute configuration, later on bromo and chloro. Ethane is the parent chain. This is the way name of the organic compound will be designated. R, bromo, chloro, ethane is the name. And where these bromochloro are present, wherever functional groups are there, that carbon is considered as the number 1. So that need not to mention, they are on 1 bromo, 1 chloroethane. So it is right, it is fine. You can write it as a bromochloroethane. This is the way name can be assigned for the compound whichever provided as per the RS nomenclature in accordance with the IUPAC protocols. Move on to question number 2. Question number 2 is collected from Cambridge Assessment International Education. Which solution has the lowest pH? Lowest pH denotes highest acidity, right? This is in accordance with the pH scale, which is formulated by the Sorensen scientist, and the pH scale is an indication for the nature of all the compounds in the range of 0 to 14. If the compound laying in between 0 to 7 is said to be acidic, 7 to 14 is said to be basic, in between exactly at 7 that is said to be neutral. So that in order to categorize nature of the compound into acid, basic, neutral, Sorensen pH scale plays a prudential role, right? So here, whenever you observe all the solutions, all are given with 0.1 moles per decimeter cube solutions. So that need not to worry about the concentration, because all options are provided with same concentration, no? So that concentration is nullified over there. And move on to the solutions: ammonia, ethanoic acid, hydrochloric acid, lithium hydroxide. If you observe the compounds, so here the fundamental is more the acidic, more the strong strength of acid, least will be the pH. Among all, ammonia is the weak base, lithium hydroxide is the strong base, ethanoic acid is the mild acid, hydrochloric acid is the mineral acid, which is indeed a strong acid. So that strong acid is obviously having lowest pH, so that it is mentioned with the tick mark. So let me give the statistical data regarding the pH scale values of all the components whichever provided in the problem. pH range of hydrochloric acid is in the range of 2.9 to 3.01. This is very least value. And 1 molar solution of domestic 1 molar solution of vinegar. Vinegar means what? Acetic acid if taken. Here concentration is higher, so that it is given with 2.4. Actually, if diluted 0.1 molar concentration if you are taking, its value still decreases. That means it still increases. pH value still increases, sorry. And typically pH of ammonia is in the ammonia is a well-known mild base, so that let me mention 11 to 12. And lithium hydroxide, lithium is a kind of what? First main group element, that is S block element it will be, right? Lithium hydroxide, some extent of covalent nature will be there, so that its alkalinity is somewhat less in comparison to the another elements as we are descending down the group. That's the reason why it is near to 12 only, so that least pH among all is accorded for hydrochloric acid. Here, if you observe this, vinegar means acidic acid only, but 1 molar solution is having 2.4. If you go with 0.1 molar, its value drastically increases. It is beyond this 3.1. So that, the compulsory condition, only the relation between the acidity and pH will be stronger the acid, least the pH, right? So obviously mineral acids are more strong in comparison to the organic acids. That's the reason why we have to put C as the correct answer. For question number 2, option C is the correct answer. Move on to question number 3. Question number 3 collected from JEE Advanced 2019 question paper. Paper 1 question it will be based on the compounds of group 15. 15 group elements of nitrogen, right? Group 15, the correct statement is R. Okay. So what are the correct statements we have to identify? Bismuth pentoxide is more basic than nitrogen pentoxide. NF3 is more covalent than bismuth fluoride. pH 3-phosphine boils at lower temperature in comparison to ammonia. Nitrogen single bond is stronger in comparison to phosphorus single bond. So we have to anticipate which are correct answers. Multiple options are correct over here. So the expected answers are A, B, and C. All 3 options are correct. D is wrong one. Let's justify. How can we say A, B, C are the correct answers? First of all, we have to look into 15th main group elements: nitrogen, phosphorus, arsenic, antimony, bismuth. So as we are descending, some trends are occurred in the periodicity of all the elements. Being it is the 15th main group, so that some of the kind of properties will be gradually changes from top to bottom, right? And the first one, what they are saying, bismuth oxide is more basic in comparison to nitrogen oxide, right? So nitrogen is at the top of the group and bismuth is at the bottom of the group, and they are saying nitrogen oxide and bismuth oxide they mentioned. Okay, so there is a condition. As we are descending, basic nature gradually increases, right? So that nitrogen is acidic, bismuth is basic. That is a common thing applicable to all the main groups. Fine. So that whatever oxides of nitrogen are acidic in nature, whatever oxides of bismuth are alkaline, are basic in nature. So they said that bismuth oxide is more basic in comparison to nitrogen oxide. Absolutely correct. Nitrogen trifluoride is more covalent than bismuth trifluoride. This is also correct. That is also called as a periodic property. Okay. How can we say periodic property? Covalent nature is purely dependent upon the electronegativity difference of binding atoms. Okay. So if you are considering nitrogen and fluorine, bismuth and fluorine, nitrogen, fluorine are having compatible electronegativity. Fluorine is more electronegative, obviously highest electronegativity element in the entire periodic table. If you go with nitrogen, nitrogen is also the electronegative element. That's the reason why nitrogen fluorine electronegativity difference is almost negligible, we can say. Let me show the periodic table containing the electronegativity values. Yes. If you see nitrogen electronegativity value is 3.04, fluorine electronegativity value is 3.98. This is almost negligible, we can say. Third most electronegative element, fourth most electronegative element in the periodic table. So that electronegativity difference among nitrogen fluorine is the least. That's the reason why both are mutually sharing the electrons. Sharing of electron gives the higher covalent nature as per the Fasen rules. But in case of bismuth fluoride, bismuth is the metallic nature containing element. Fluorine is the electronegative. So bismuth is electropositive, fluorine is electronegative. Obviously, there is a charge separation. Bismuth having electropositivity, fluorine is having electronegativity. So the transfer of electrons we can notice. So bismuth trifluoride is said to be ionic in nature, maximum extent rather than covalent. So NF3 is having more covalent character, bismuth trifluoride is having least one. This is also correct one what they are saying. Move on to option C. pH3 called phosphine boils at lower temperature in comparison to the ammonia. Exceptional high boiling point accorded for ammonia, water, HF. These three elements, these three compounds are having highest boiling point values in general. That is purely because of a hydrogen bonding. Hydrogen bonding is indicated with the dotted line bond only. Being it is a weak bond only, but significant role in the existence of the compounds and their physical properties, some extent chemical properties also altered, right? So if you observe the ammonia molecule, hydrogen bonding is the type of weak attractive forces mentioned with the dotted line bonds in between the electronegative atom and a nearby hydrogen atom. Exceptionally, three elements of the periodic table are showing this hydrogen bonding. One is fluorine, second is oxygen, third is nitrogen. Apart from these three, no other element able to show the hydrogen bonding. Okay, so if you observe this, it is made up of nitrogen, no, and adjacently you can find hydrogen. So that there is a provision to form a hydrogen bonding. So nitrogen is acquiring partial negative, and this del sign indicates what? Partial sign. Okay, not completely polarized, rather a partial kind of location, partial existence of charges are possible. Hydrogen is acquiring partial positive charge. This is the way charge separation is noticed in the hydrogen bonding among nitrogen and hydrogen. Because of this nitrogen hydrogen bonding formation, this is called intermolecular hydrogen bonding. Intermolecular hydrogen bonding is holding the molecule firmly. The molecules are not escaping one in either. Rather, all are holded with a bond formation. That's the reason why all are existing in the liquid form. All are existing with such a kind of bonding nature. That's the reason why, in order to break these additional bonds, so we need to supply the extra energy. So boiling point values are higher for these ammonia molecules. But in case of pH 3, there is no such existence of hydrogen bond. Hence, we can easily vaporize them, so that pH 3 boils at a lower temperature in comparison to ammonia molecule. So this is also absolutely correct. Move on to option D. Nitrogen single bond is stronger in comparison to the phosphorus single bond, right? So this is the way we can explain about this one. Nitrogen single bond is weak, or phosphorus single bond is weak, we have to discuss. So phosphorus single bond is stronger in comparison to the nitrogen single bond. What they are saying is not correct. PP bond is stronger in nature. That's the in order to explain this one, we can go with lone pair repulsions. Okay, nitrogen single bond. So if you see the nitrogen in comparison to the phosphorus, nitrogen is the tiniest. Being it is a smaller, that is accompanied by the lone pair electrons around. Nitrogen is having lone pair, and either nitrogen also lone pair. Both are together. Whenever two lone pairs are in the closure vicinity, they will repel each other. Whenever repulsions are possible, the bond is not that extent stable, so that it will be a weak bond will be there. But if you observe the phosphorus atom is somewhat larger, so that bond length is somewhat longer. Whenever bond length is longer, what happens? The electrons, same number electrons only there, but distance is somewhat larger. Being the distance between two lone pairs are longer, what happens? They are not that extent repelling, so stability is somewhat increased. That's the reason why we can say PP bond is stronger. That is purely because of larger size of phosphorus, which makes the distance of the bond, which minimize the repulsions between the lone pair of electrons around them. So here PP bond is stronger in comparison to the NN bond, right? So A, B, C are the correct statements. For question number 3, option number A, B, and C are the correct answers. Move on to question number 4. Question number 4 is collected from the organic chemistry session. And in the following reaction sequence, the correct structure of X is. The correct structure of X is to be identified. In order to identify the X, the reagents to be taken and the product will be formed. The reagents are phosphorus tribromide, diethyl ether, sodium iodide, dimethyl carbonyl, and sodium azide HCONMe3, dimethyl formamide. This is designated as N-dimethyl formamide. Whenever these many series of reactions are carried, the expected product is a 5-membered ring with azide on one side, methyl on another side. This is said to be a 5-membered cyclic system. Fine. And starting material is expected to be B. On B, what you can notice, one side we have methyl, in product also we have methyl, so that methyl is inoperative, that is not reacting. Methyl is not the reacting functional group over there. Whatever there in the starting material, that again there in the product as well, so that it is common. Move on to this part, which is active, that is OH. Hydroxy is there, that hydroxy will be reacted with these many series of reactions, and that converted into azide, so that B is the product. Let's see how can we explain this. First of all, this hydroxy will be treated with PBr3. This is called phosphorus tribromide. Phosphorus tribromide is the halogenating agent. Whenever halogenating agent is added in the presence of diethyl ether, this is called what? A solvent, organic solvent. So what happens here? OH will be replaced with bromo. Later on, sodium iodide will be added. Again, it is the kind of substitution, we can say. Existing group will be replaced with iodo now. But if you observe the things, what happens? OH is a wedge bond. Wedge means dark bond, means towards you, towards the VR. But it is participating in SN2. SN2 means bimolecular nucleophilic substitution. Whenever any molecule is participating SN2 reaction, what happens? Whatever stereochemistry is there in the starting material, that will be completely reversed. That will go back. It is front side, now it is back side. It is hydroxy, now it is bromo. After getting bromo backside, again you are treating with sodium iodide. Sodium iodide releases I- nucleophile, which is coming from the front side. Bromo will depart from the back side, that is SN2 again, so that you will get iodo in the front. Again, it is the stereochemistry inversion. So stereochemistry inversion is possible. Backside now turned into front side, right? Later on, what we have to add? NaN3DMF. Dimethyl formamide is the solvent and sodium azide is the reagent. So in the sodium azide, you can find N3 minus as the nucleophile. N3 minus is called azide. That azide will be added. Again, it will be going from the back end and iodo will be departing from the front end, so that we will get azide in the back end. So these many series of reaction, but there is a common thing among all, that is SN2, SN2 and SN2 as well, right? So this is the way we can go for a reaction. If we are strongly aware about these many kind of reagents, then only it is possible to go for how we are getting the product. What is the stereochemistry? Stereochemistry stands for how the localization, how the orientation of the functional groups around the carbon is said to be a stereochemistry. Stereochemistry is the most important. It matters for its properties, right? So for question number 4, option number B will be the correct answer. Move on to question number 5. Question number 5 collected from Telangana Gurukulam Common Entrance Examination for this is the MSET examination conducted in 2023. So that 2023 MSET examination conducted by Telangana state government. An electron is moving with the kinetic energy 4.55 into 10 to the power negative 25 joules. Its de Broglie wavelength in nanometers is. Mass is given by 9.1 into 10 to the power negative 31 kilograms. Planck's constant value is given by 6.63 into 10 to the power negative 34 joules a second. Okay, electron 4.55 into 10 to the power 25 joules la గతి శక్తితో చలించుచున్నది. దాని de Broglie తరంగ దైర్ఘ్యం నానోమీటర్లలో. de Broglie తరంగ దైర్ఘ్యం నానోమీటర్లలో కనుక్కోవాలి. Okay, na? So here electron is moving with kinetic energy. In order to answer this one, the expected answer is 728.5 nanometers is the correct answer. In order to calculate this value, we have to use the formula lambda is equal to h by mv. Lambda is equal to h by mv is the de Broglie equation, right? Here the entire values are provided in the detailed manner. Lambda denotes wavelength. H is the Planck constant value, and m is the mass of particle, v is the velocity, speed of the particle, right? So all the values in this wavelength to be identified, to be calculated. Planck constant is the value, constant always. Mass also provided within the data. Velocity, we will calculate over there, right? In order to get this one, there is a formula. Kinetic energy value is kinetic energy value is calculated by half mv square, half mu square, or else, right? Half is the numerical value only, m is the mass, u is the velocity, that to be calculated now, right? So here u square will be there. So kinetic energy value is known to you, right? So here velocity is unknown to you, then velocity square can be taken this side. Now it will become kinetic energy. Kinetic energy is given as 4.55 into 10 to the power negative 25. Half is nothing but 0.5. When u square taken this side, this half will become denominator over there. Okay, mass value is given within the problem, that is 9.108 into 10 to the power negative 31. This is the value for u square. So if you make u, so what happens? Whatever value is there, that is becoming under root. So after calculating the entire numerical terms, the u, that is velocity, is calculated as 10 to the power 3 meter per second. Okay, lambda is equal to h by mu. H is the Planck constant, m is the mass, u is the velocity. So h of Planck constant 6.626 into 10 to the power negative 34. Mass is 9.1 into 10 to the power negative 31 kilograms. U is just calculated 10 to the power 3. If you substitute all the values in the equation, lambda is calculated as 7.26 into 10 to the power negative 7 meters. There is a logic. So, but they are asking in a nanometers. We got meters value. How to convert meters into nanometers? 1 meter is equal to billionth of nanometer. These many zeros will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 to the power 9. 1 meter is equal to 10 to the power 9 nanometers. Okay. So then the value is 7.26 into 10 to the power negative 7 is equal to how many nanometers? So that cross multiply 7.26 into 10 to the power 7 into 10 to the power 9. So that the value will become 726 nanometers. This is the way calculation will be carried. And last question of the session, sixth question of the session. In which of the following, the order of the element and periodic property is not correctly mapped? In which of the following, the order of elements and the periodic property is not correctly mapped? That we have to identify. This is the question given from periodicity of elements. Okay, here fluorine, chlorine, oxygen, nitrogen, their electronegativity values. Runavidyudatmakata values ichindru. Chlorine, fluorine, bromine, iodine. This is related with electron gain enthalpy called electron grahya enthalpy. Aluminium, beryllium, boron, carbon, atomic radius, paramanu vyasartham. Fluorine, nitrogen, oxygen, and carbon. First ionization enthalpy, prathama ionization enthalpy. These many values are given, which is not correctly mapped. That is option number 1. Option number 1 is not correct. Let's see the justification. So they are saying that fluorine followed by chlorine followed by oxygen followed by nitrogen. This is the order of electronegativity. Let's see the statistics. Fluorine value is 3.98. Oxygen is 3.44, but chlorine is 3.16. So oxygen value is higher in comparison to chlorine. Oxygen should come front, chlorine should go there. Fluorine, oxygen, chlorine, nitrogen will be the right order. This is only the odd man out. You can point out this is not the correct answer. Okay, so that it will be ticked. So electron gain enthalpy. So here, exceptionally, chlorine is having higher electron gain enthalpy in comparison to fluorine, followed by bromine, followed by iodine. So most of the people think that whatever electronegativity values are there, electron gain enthalpy values also similar, but that is wrong thinking, because chlorine electron gain enthalpy is higher in comparison to fluorine. This is exceptional condition in the periodicity. That is purely based on the size of the atom. Fluorine is resided with the 7 electrons in the valency shell. Chlorine is also with 7 electrons, right? So in order to gain the electron, fluorine size is tiniest one, so that whenever electron is absorbing, that is not capable to hold or manage the repulsions among the electrons, so that energy released during the acceptance of electron will be extremely lower because of repulsions, being it is a smaller. But in case of chlorine, the shell is somewhat larger, and the occupancy for the electron and the minimization of the repulsions are more, so that chlorine is highly favorable for accepting the electron and releasing highest amount of energy, that is called electron gain enthalpy, right? So this is the correct order for electron gain enthalpy values. And move on to aluminium, beryllium, boron, carbon, atomic radius. Let's move on to atomic radius comparison. Beryllium is said to be 19. Aluminium is said to be 118. So that aluminium size is larger. Boron is 82 only. So first aluminium followed by beryllium followed by boron should be there. Is it true? Aluminium, beryllium, boron, and carbon. Let's compare with carbon. Carbon, where are you? Carbon atomic radius is still least. Okay, how can we explain this kind of order? Means that is the periodicity. When we are moving from left hand to right hand side, so in the period, gradually size of the atoms decreases. So that we can say beryllium is of S block element, larger in nature. Boron is of P block element, 13th group. 14th group is carbon. What happens? Beryllium to boron, boron to carbon, size gradually decreases. This is a periodic trend. Okay, so this is commonly observed. But why they mentioned aluminium in front of all the elements? Because where aluminium is laying on the in the second one. So beryllium, boron, carbon all belongs to same period, no? But if when you go to aluminium, one more extra shell is added over there. That's the reason why the size of aluminium is still increased, because we are moving a step ahead. Aluminium, in order to move to aluminium, boron to aluminium, you're increasing one step, so that one more shell will be added. Whenever one more shell is added, the size will be increased. That's the reason why aluminium is the largest, followed by beryllium. Boron, carbon is the tiniest one. This is regarding what? Atomic radius, right? Move on to last option, fluorine, nitrogen, oxygen, carbon, right? First, ionization enthalpy values, right? First, ionization enthalpy. What is ionization enthalpy? Ionization enthalpy stands for amount of energy required in order to remove the electron from 1 mole of the gaseous atom is called ionization enthalpy. So we need to remove the electron. In order to remove the electron, will fluorine will remove its electron? Obviously no, because fluorine is the highest electronegative element. Always it wants to take the electron. Why? It will give the electron. So there is no choice to release the electron. So we require highest amount of energy to remove the electron to make the fluorine positive. In the practical sense, fluorine will not exist in the positive value. So positive convention may not be possible for fluorine. And the next followed element is nitrogen, followed is oxygen, and the least will be given for carbon atom. Here is the ambiguity, nitrogen and oxygen. Why nitrogen coming first in front of oxygen? Actually oxygen should be there, no? Because after fluorine, most electronegative element is oxygen only, but not nitrogen. Let's see the quantified values. Fluorine electronegativity is 3.98, but oxygen is 3.44, but nitrogen is 3.04. Is this correct order? Why nitrogen is front in comparison to the oxygen? Though oxygen is more electronegative than nitrogen, why nitrogen is not able to release the electron? Because nitrogen is said to be half filled. Half filled means what? NS2 NP3 configuration is there. Completely filled and half filled orbitals are having highest stability. That's the reason why nitrogen is very hard to remove the electron, and it is said to be an inert gas. Though it is not a noble gas, but inert in nature because of its half-filled stable configuration. Hence, it's very difficult to remove the electron. Latter will be given for oxygen, and more labile will be carbon. This is the way first ionization enthalpy order will be assigned. Among all the wrong mapped one is fluorine, oxygen, nitrogen in accordance with the electronegativity. For question number 6, option number 1 is the correct answer. By this, we entirely completed the session where all the corners of chemistry got covered, and we dived into various sections of the chemistry. This will definitely increase your thirst towards learning chemistry, and you will improve your interest towards learning of oceanic chemistry. So that I'm sincerely requesting to like the channel, comment which part is most important for your serious preparation, share with the aspirants who are serious about the examinations, and subscribe the channel with what new kind of updates in the near future. Thank you one and all for your patient listening.